Hey, Year 10. This is week 3 of algebra. So last week we asked you to work on expanding binomials, so like 2 sets of brackets. From what I've seen and students who have reached out, you've got the basics, you understand how to do it. There might just be some algebra stuff that we need to work on, which is totally fine. So when you have powers and other variables included. What I want to do today is factorize trinomials or quadratics. It's a scary way of saying undoing what we've just done. So if I scroll back here, in last week's lessons, all I asked you to do is expand these kind of questions. Okay, when you do that, they're going to turn into this kind of form that we're looking at today. Okay, so just being able to go back and forward between the two, and I'll also kind of explain to you really quickly why that's really useful going forward. What I want to start by doing, and if you are totally a-okay with expanding binomials, you can kind of skip forward until you see us go back down to this screen, and that's where we're actually going to do the factorizing. But I want to start by going through maybe the bottom 4 questions here, just to kind of give a recap for anyone who's still a little bit unsure on expanding binomials. Okay, so when you expand, you can either use your grid, which is that kind of like times tables, have E and negative f and E and positive f, and then you're filling in all the gaps. So E squared, EF, negative EF, negative f squared, and then you write that out as a list. When you do that, you have positive EF minus EF, they're going to make 0 EF. So that's going to go away, and you're just left with this. Another method you might like to use is the idea of FOIL, and that is to say you times the first 2 things together, like we just did, get E squared, and then you're going to times the outside things together. So E times F is EF, I is for inside, so negative F times E, and then finally L is for lasts, so FOIL, and we get this, and then you still need to do that last line to get rid of EF and negative EF because they cancel each other out, and this is our answer. So whichever method you prefer is totally fine. The only trick with these squared ones is that squared means it's multiplied by itself, okay? And then if you were to use that same method, again, I prefer the grid. I think the grid's a little bit nicer. Okay, so you go 4m, negative 7, 4m, negative 7, particularly when you're just starting out with this. 4m times 4m is 16m squared, minus 28m, minus 28m, plus 49. You don't need to write plus there, but I'm just making sure I realize for myself that it's not negative anymore. Now when I do my final answer, I'm going to get 16m squared. Oh, I lost it. What am I going to get? 16m squared. You're going to have negative 28m, negative 28m, plus 49. And with these, we're often going to be able to clean up those middle terms, the inside and outside bit, and that's going to get me negative 56m plus 49. Okay, same idea with these ones. I might just do 14 because 12 is quite easy. It's the same deal. If you need help with this, please reach out because it is super duper important. We'll just go with FOIL this time. So you got times the first things together. 7 times 7 is 49. N times n is n squared. And then we're going to do the outside inside. Notice because it's a perfect square in terms of just one bracket squared, we call that a perfect square, that the outside times the inside, the outsides, whatever you get, and whatever you get for the insides is actually going to be the same thing. That's always going to be the case for these perfect squares. So I get negative, we'll do outside, so 7n times negative 12m, negative 84mn. And I'm going to get the same answer for the inside as well. And finally, positive 144m squared. The only trick here at the end is just to tidy up the things that we can. It's usually going to be those middle terms that can be tidied up. It's very rare for it to be the first or last thing. So you look at this middle bit, that's just going to be negative 168 mn. Okay, so hopefully that's a little bit of a recap, refresh your memory on how to expand, And now we're going to undo all that work with this topic here. So what I'd like you to do to start with is have a look at this kind of like puzzly fill in the blanks kind of thing. So we've got this statement here, this expression. And if I was going to factorize this, so put it back into brackets, unexpand it, I'm telling you that one bracket has an X and one bracket has a Y. I want you to figure out what would go in each of these boxes. If you reckon you can have a go at this on your own, pause the video and have a try. For those of you that definitely didn't pause and just stuck around anyway, we'll have a quick look through how this works. So generally when you write out this expression, and I'm going to tell you I've written this one out this way, this term here is going to be what you get by multiplying your firsts together. So that means over here with our brackets, multiplying our first two things gets me xy, and that checks out. The next two parts are going to be our outside and our inside, okay? So you need to say to yourself, well, the outsides is x times this. What times x is going to get me 8x? That must be 8. And then you can say to yourself, okay, well, this is the insides. So what times y will get me negative 3y? That must be negative 3. Keep in mind you can get negatives in these as well. And finally, just to check that that works, this is our lasts. Do I get negative 24 when I do negative 3 times positive 8? That checks out as well. Okay, so that's what we're doing here. But you'll notice with the examples we're about to step through, they don't have first, outside, inside, last, because that outside, inside can usually be brought together. That's the only trick here. If we had that outside, inside, easy, right? But that's why we're going to do like a couple of steps to help us figure that out. But what we can always figure out is our first and our last quite easily. So let's go through it. When we break this up, this is going to be our firsts, this is going to be our lasts. We know that. This is going to be the combination of the outside and inside products. The way you want to do these is to always start by considering this last term. In other words, what do you get when you multiply these two numbers together? And for most of our cases, they are just going to be numbers, but yeah, they could have algebra, they could have fractions, stuff like that. So I need to say to myself, what numbers, and think whole numbers, nice numbers, we're not going to make this awful for you. What numbers can multiply to get me 9? Okay, what are the factors of 9? I like to write these out as a little list just when I'm starting out. Eventually you'll do this in your head. And so you can say to yourself, well, 9 and 1, and I'm not going to write 1 and 9 as well because they are multiplying, the order doesn't matter. So 9 and 1 or 3 and 3. They're my two options. Now what we need to consider is, can I use the numbers 9 and 1 to make negative 6? And what I mean by that is, could I go like 9 minus 1? Could I go 1 plus 9? Could I go like 1 minus 9? Any combination of those to get negative 6? No. I hope you can realize that I can't use those, so it mustn't be 9 and 1. So then we go to 3 and 3, and usually there's only going to be 1 or 2 options you can go through. So don't worry, there's not going to be too many questions where you have to write out a big list and go through. So with 3 and 3, is there some way that I can make that negative 6? Hopefully what you can realize there is, well, I can go negative 3 and negative 3. Okay? Because if I have negative 3 and negative 3, that gets me this negative 6. Notice I'm not worrying about that x, I'm worrying about the number in front of x. So negative 3 and negative 3 will give me negative 6. That works. We're basically done. All we've checked is the factors of the product, that last number, which you get from your lasts, right? We've made a little list of those. We haven't doubled up. We haven't gone 1, 9 and 9, 1 and 3, 3 and 3, 3. We've just done each step. And then we've said, can those numbers make this middle term, just that middle number, so negative 6? I can't do it with 9 and 1. I can do it with 3 and 3 by making them both negative. Now when I get to my answer, I know that my first terms what times what is going to give you x squared? That must be x times x. And that's how I can get my firsts. Very rarely is it not going to be x times x. And in fact, we're going to go through in the next lesson what happens when there is a number out the front. And it's a bit of a cheat that we're going to use. And now what we said before is, this only works when these are both -3. So I can pop those there. The very, very last step, and this is something that a lot of people forget, is x is going to be equal to, okay? And in fact, we don't even really need to do this step yet. If you were to get to this point, you're totally fine. But this is going to be really useful down the track. X is going to be equal to what makes each bracket equal to 0. So what I mean by that is, what number would you have to put in here for x to make this bracket 0? And hopefully that's really obvious that that number must be 3. You go 3 minus 3, that's 0. So that is what x equals for this bracket. And we're going to do the same thing for this bracket. We're going to say what number. You'll notice it's the same because this is one of those perfect squares. So x equals 3 again. So this is the whole thing. This is going beyond what we need to do. All we need to focus on today is factorizing. So getting to this line here, okay? But all solving these quadratics is once you're at this point, you're just saying, well, what makes this each bracket 0? Another way of saying that is it's always the opposite sign of this number. So if this was -3, this would be +3. If this was +3, for example, then our answer would be -3. Okay, so for the other ones, all I'm going to do is take you to this line though, because that's all we really need to be doing for now. Okay, so let's have a look at this one here. So we're going to be factorizing. Again, this is my firsts, outside and inside, and my lasts. Definitely, like, the more confident you get, take steps away. This is totally unnecessary if you know what's going on. Now, we're going to use our lasts because that's going to tell us what the numbers multiplying are, okay? So the factors of 4. Well, I've got some options. It could be 4 and 1 or 2 and 2. And now what I need to consider is, can I, only by adding and subtracting, can I make -4, notice this time we're taking the negative as well, with the number in front of x, can I make -4 using either of these numbers? There's no way to make -4 out of 4 and 1, because let's say I had -4 plus 1, that doesn't work. If I had 1 minus 4, doesn't work. If I had -4 minus 1, it's -5. So I can't do it with 4 and 1. Can I do it with 2 and 2? Well, -4 is going to be -2, take away 2 more. So I can do it with 2 and 2. They just both have to be negative. Okay, and there are some examples where, let's say that number there was -2, then, oh, that's a bad example. Ignore me, don't worry. We'll get to one where you don't always have to have negative. That's just been a coincidence. Okay, so now when we finally write our answer, all we have to do, it's x and x, because x times x gets me x squared. And then I'm going to say my numbers that are going in here and here happen to be -2 and -2. And if you want to double check that for this one, again, we'll do an extra step that we don't need to do. If you expanded this the whole way through, you'd get x squared minus 2x minus 2x plus 4. And if you were to bring those minus 2x's together, then you would get this same expression up here. So you can always use that to check your answer, even though I know you'll never actually check your answer because nobody does. Okay, now I'll quickly talk to you about why before we get like a couple more practicey ones in. This here in red is the graph given by this equation. You'll notice it's this quadratic where you have an x squared, an x and a number. That's the pattern we've been working in. And you'll notice I've listed 2 specific points here. Now, if we were to factorize this x squared minus x minus 6, okay, we'll do the same method we've been doing. You look at 6 and you say, well, the factors of 6 are 6 and 1, or 3 and 2. Can I make, now this is a tricky one because the number in front of x here is negative 1. Even though it doesn't say 1, you got to remember that there's always a 1 there. So can I make negative 1 out of either of these sets? I can't do it with 6 and 1 because it's either going to be a 7 or a 5. Okay, so that's no good. But with 3 and 2, how do I get negative 1? There's plenty of ways. You could say 2 and minus 3, because that's going to leave me with negative 1. You could say minus 3 and 2. That works as well. To show you that like double negatives doesn't work in this case, negative 2 take away 3 more is negative 5. So regardless of the order you wrote it in, we know that the 2 has to be positive and the 3 has to be negative. So our answer is going to be positive 2, negative 3. And that's factorized. What I talked about in that first example is what we're going to be working on. This whole next topic after all this is your actual x values are going to be what makes each bracket 0. So in this case, this x is going to have to be negative 2, and this x is going to have to be positive 3. Now, what I want you to notice about these answers that we got here are where they match up with this graph. Okay? Now, graphs for you probably aren't very interesting yet, but it's going to be the basis of pretty much everything you do in advanced and extension maths. And especially if you're going to do anything at university with analytics or maths, it's all based on creating an equation, using that to model a graph, and then working from there. So it's really important. And this idea of factorizing and then being able to solve for the x values, what you're actually finding is the x intercepts, and I'll write that on here, of a graph. Specifically, this shape here, this UE shape, is a quadratic graph. Okay, again, please don't get overwhelmed. All I need you to do today is this step here where we're factorizing, but I think it's really important to understand why this matters so much and where it's going to keep coming up. Okay, so we've got a couple more examples to go through. If you're good, feel free to skip ahead, do the maths-based task or the textbook work. Otherwise, I'm just going to go through some really slowly so you can skip through at your own pace. So here, we're going to start with our product at the end. Numbers that make 8 are 8 and 1, 4 and 2. And you say to yourself, can either of those pairs, by adding and subtracting, make positive 6? I can't do it there. I can do it here if it's 4 plus 2. That means my answer must be x plus 4 and x plus 2. Factorized. Okay, this one's a little bit trickier. We're doing some yucky numbers, all right? So now we're going to have to list quite a few factors because 60 has got quite a few factors to it. So 60, what could we do? We could do 6 and 10. We could do 30 and 2. We could do 15 and 4. We could do 12 and 5. And we could do like 60 and 1 even as well. There might even be more there that I've missed. But just writing them out doesn't take long. And then all we're going to do is check, can I use those numbers to make negative 17? And the more you do this, you'll get really quick at it. 6 and 10, I'm either going to get 4, which is the difference, or I'm going to get like some form of 16, whether it's negative 16 or positive 16. So that's no good. 30 and 2, clearly not. I'm going to end up with like 28 or 32. 15 and 4, I can get to 19 or I can get to 11. That's no good. 12 and 5, I can either get to 17 or 7. The 17 is interesting, and quickly 60 and 1 clearly doesn't work either. But 12 and 5, I can get 17 by adding them together. So counter, I can do negative 12, negative 5 to get negative 17. Okay, so that's going to be my answer, negative 12 and negative 5. So that's as hard as it gets in terms of finding factors. You just got to list them out and then just trial and error, go through it. There is no better answer, really. You'll just get more confident. That's all it is. Okay, so your task for this week There is a maths-based task called Factorising Quadratics. If you're working out of the textbook, go for it. If you have been working out of maths-based and you're sick of it, and you're going, can you just give me a list of questions, kind of like what we did last week? Happy to do that too. Please just get in touch. Let me know if you need any help. Next lesson, we'll be going over factorising when we have a number out the front. Awesome. Good job, guys.